Hope everybody had a nice, restful, relaxing, easygoing spring break, and that you guys feel ready to kind of roll back into whatever this last bit of school is going to end up looking like. I wanted to start off today just going over a little bit of what my spring break looked like. I did a little bit of traveling. You guys may or may not have noticed, but my background is a little bit different. That's because I am in Colorado right now. I'm at my parents' place, and so I'm going to be recording from here for a little while. And as a part of it, I've been doing some fun things. Had a nice little road trip out here, driving along West Texas. Had a beautiful sunset. Got to see all those different gradation of colors there. The blue from those wavelengths of light that are being kind of scattered the most, right? And then the red being scattered the least was able to pass through that thicker atmosphere lower at the horizon there. And actually get to my eyes. So that's kind of cool seeing that. This was Capulon Volcano National Monument. It's one of my favorite little spots in New Mexico. Highly recommend stopping there if you're ever driving out this way. Continuing, finally got into Colorado and was able to see the Sangre de Cristo mountain range there. Very pretty. And then I finally got home to my house. This is actually my house back here in Colorado. This is my parents' place. No, I'm just kidding. This is actually in their backyard, but I do not actually live in a teepee. I have slept in there before. It's quite cozy. But this is essentially my parents' backyard. There's just over a little rise from our place. You can see these mountains from their house, and this is just a really good view of them. So it's a really pretty spot. It's fun to be back. And right here, this little notch to this mountain is actually kind of where my cabin is, and we'll get there in a second. So I've just been kind of hanging out, doing some fun stuff, shooting some arrows with my brother, doing some archery, hanging out up on my garage. We just put in some solar panels, right? So harvesting energy from the sun there, which is kind of cool. And got some chickens. Got a little video for you guys. My parents have chickens. They've got 10 of them. And they're wild little things. They're very, very strange. Very entertaining, though. And we have a lot of fresh eggs. So that's kind of cool and unique. Like I said, I did a little bit of skiing. This is my cabin. I think I mentioned that to you guys before. I went skiing with my buddy Steve. We stayed at least 6 feet apart. Don't worry. Staying safe out there. But hung out up there for a little while. This is the view. Those are the same mountains that we could see from my parents' place. And so it's very pretty. There's still a lot of snow up there. Surprisingly, there's about 3 feet on the ground still of compacted snow. So a good bit of snow. We hung out on the porch for a while, and there's this little fox that came by. Actually just started trotting down and had a seat and kind of chilled with us for a little bit of time, and that was cool. Been getting out on the river a little bit as well, so going straight from snow to the snow melt. I went rafting the other day in my raft on the Colorado River. Saw a cool old car buried in the bank, found some fossils, some old nautiloid fossils. And this is actually a trip I was really looking to find some hot springs. I'd been doing some research on some hot springs that are along the river there that I wanted to check out for a little while. And so I found 3 kind of major springs and a bunch of smaller ones. And it was really cool. They were relatively warm, kind of mucky and gross, but this one was the most interesting. It was only about a foot deep, surrounded by algae, but it had this spot in the center, which was just this kind of bubbling, kind of like mud and silt. And I was a little bit wondering like what was in there. You can see it kind of bubbling. And so I stuck this stick down in there, and it's about 4 feet deep, right, before you actually hit kind of like solid ground again. It's just kind of like this stew, this really like liquid silt, which is kind of cool. And it's this water, it's like 100-degree water that's boiling out of there. So that was something pretty cool. So that's what I've been up to. All the excitement here. And then now getting back to the school thing. So I want to start off saying I read you guys' survey, and we're going to make a few changes based on kind of what you guys said there. One thing that really kind of stuck with me is one person said, I just don't feel motivated to do schoolwork because it feels like school's over. And I will say, especially being on spring break, it certainly did seem that way. I felt like we're just kind of going through the motions, and it is a little bit of a strange position that we're in right now. So one thing that I want to do with you guys at the very least is I want to just try and generate and instill in you guys a general curiosity about how the world works, so that you guys can continue to ask questions and seek out answers. Just building and developing that curiosity about things is really important to me. So I'm going to try and avoid doing busy work as much as possible and just focus on learning material, maybe doing fun little like at-home labs and stuff like we'll do today. And that's going to be that. One big change is going to be made. is that the due dates are going to be moved to the next day at midnight, right? So you will have 2 days to do assignments. That was kind of a popular request. I still recommend trying to do them the day that they are put out, just like being in class. Right? You go to class that day, you do the work in class, then you're pretty much done, right? But if you guys need an extension, then you have 2 full days. So hopefully I'll take a little bit of stress off of you guys. I wanted to bring this up. I'm going to start taking off points for late work if you're not properly communicating what's going on. If you have stuff that's going on at home, if you're having a hard time with like internet connection or securing a way to access the materials, or if there's just other things that are going on in your life that are making it really hard to do the work, that's fine. I'm very flexible with like deadlines and due dates and those kind of things, but I just need you to communicate, right? That's the most important thing that I can stress, because otherwise I don't know what's going on. Okay, so today we're actually going to be starting Unit 11, which is all about optics, right? A quick refresher on what we've learned about so far about light in Unit 10, which was about light and electromagnetic waves. We learned that light is an electromagnetic wave. This is an oscillating electric and magnetic field that travels through space. They're created when a charged particle accelerates, if you guys remember that. So if we have like a positive or negatively charged particle, like a proton or electron, and it accelerates, either speeding up or slowing down or vibrating back and forth, it can create an electromagnetic wave that travels through space. These waves carry energy, and they each have a unique wavelength and frequency, but all of them travel at the speed of light. Right, so all these electromagnetic waves travel at the speed of light. We can calculate or measure the wavelength, frequency, and energy of these using our equations here. The speed of light is equal to the frequency times the wavelength, and the energy in that light is equal to the frequency times Planck's constant. Hopefully you guys remember us kind of applying those equations a little bit. There's a whole spectrum of these electromagnetic waves, from radio waves to gamma waves, going from least energy to most energy. And those waves with a wavelength between about 400 and 700 nanometers can be sensed by our eyes. Right? So that's the visible light range. Our eyes can actually pick those up with our cones. And we talked a little bit about how colors work. Right? So our eyes and the cones in our eyes can sense differing intensities of these wavelengths, and our brains interpret this as colors, right? Which allows us to see. Hopefully you guys really enjoyed and got a chance to listen to that Radiolab podcast. It's one of my favorite things, really. It's kind of crazy to think just how much what we see and color is in our head, right? We like to think maybe that it's just this thing that happens and that we'll always be able to see these colors. But there's some really interesting stuff, especially like where they talk about that tribe where they don't have a word for the color blue, and so they show them those green squares and there's one blue one, and they just can't see it because they don't have a word for it, right? There's a really strong connection between words and our senses, and just because we have the hardware, right, the nerves and the cones to sense these light waves, doesn't mean that we can actually process them in our brains and turn them into these colors, right? So it's actually a pretty complex thing. But in this class, we've mostly been focusing on just the physical reality that there are these light waves that we can sense some of them with our eyes. We can sense them in other ways using special technology. And anyways, so when these light waves, it can be visible light, it could be infrared, it could be ultraviolet, any of them, when they go from one medium to another, right? So from like air to like my hand, from air to the camera, from air to your eye, from air to water, from air to a leaf, right? When they go from one medium to another, right, there are 3 things that can happen. And this kind of brings us to where we're talking about with optics, right? That light can either be reflected, absorbed, or transmitted. Now, in the case of absorption, right, there's no more electromagnetic wave, right? That energy has been transferred to some other form, usually heat, right? But in the case of reflection, right, and transmission, right, the electromagnetic wave still exists, right? It continues moving on. And that's what optics is really about. It's looking at this reflection and this transmission, right? Optics is about how light waves move, right, through and across these different mediums. In the case of reflection, we mentioned there's specular reflection, which is where it's a smooth surface and it comes in at one angle and it leaves at another angle. Or there's diffuse reflection, right, where the surface is a little bit more bumpy and it comes in at one angle and then it leaves at a whole variety of different angles, right, depending on where it hits on that surface, right? And then with transmission, we talked a little bit about this term refraction. We're going to be learning more about that in this unit. And we also talked about how when light passes through something, it can be scattered, right? Which is kind of similar to this diffuse reflection, is this scattering. Okay, so this is kind of what optics is talking about, and we're going to start with talking about optics, just talking about the ray model of light. So previously, we've just looked at light as a electromagnetic wave. So if we draw kind of a little wave like this, right? So we've thought of light as an electromagnetic wave, right? This wave has a wavelength, it has a frequency, it travels at the speed of light, but it oscillates, right? It goes up and down, right? It is a wave and it has those properties which are very important. Now with the ray model of light, right? With optics, we're really not concerned about the frequency, we're not concerned about the wavelength, we're not even really concerned about the speed necessarily. What we are really concerned about, though, is the direction, right? And we see that this wave here is going in one specific direction. It's going from left to right here. So we could just simplify this wave as a single line going from left to right, right? So this would be the ray model of light. So this is the wave model, and this would be the ray model of light, right? So we've got our wave model and we've got our ray model, right? The ray model is very much simplified. It is just concerned with the direction. Now, this is important because if we have like a light source, for example, let's say I have like a little light bulb here. Oops. Let's say it's a terrible, terrible light bulb, but it'll have to do, right? So if I have my light bulb here, and that light bulb is producing light, so it's sending waves, right, of electromagnetic radiation in all directions, right, all directions. Now we can simplify what's actually going on there, right, by drawing it in as rays instead of waves. So there we go. So we would just draw it as a bunch of different rays going off in all possible directions, right, away from this light bulb. Now, what I could have is I could have a spot where I block these rays in some directions, right? Or I just maybe allow them to go in all the directions, right? If, for example, you had a lampshade or something, or sometimes you'll see lights that have metal reflectors, right? What that's doing is that is essentially creating a spot here, right, where all of a sudden any of these wavelengths, any of these waves that are coming off, if this is my kind of like cone, right? Oops. Right, then all of a sudden these wavelengths do not go out and all the light is just going in this direction, right? So we're kind of focusing the direction of that light. And that's what happens like if you have a flashlight, for example. It's just like that, it focuses it more in one direction. And we could focus this even more narrow to where we just get like a single beam of light, right? A single ray of light. And that's kind of what we get with a laser, right? It's just a focused single ray of light, right? But otherwise, we just have a kind of large scale light is going in all directions from this source, right? In these straight lines. So that's the ray model of light. Now we use that when talking about optics, and it's very useful because let's say that I had something like let's say I have a little scene here, and I've got like a little, here's my flat ground there, and then let's say I've got a tree. Wow, what a beautiful tree. That's actually, I'm going to redo that tree. I'm sorry, that was a really bad tree. So let's do the trunk first, and then we'll just do, there we go. That's a slightly better tree. And let's say then that I have my sun here, right? And there's my sun in the sky. Let's say that I've got a person standing here, and this, it's not to scale at all, but this is this person's eye, right? So that they can see. So here's my scene. I've got the sun, I've got this tree, and I've got this person's eye. Now let's say that there are light waves that are leaving the sun, right? And they're leaving the sun in all directions, as we mentioned. Right? Every single possible direction they are going away from the sun, right? And some of these are going down towards this tree, right? So let's say that I've got this point on this tree, and let's mark this point just using old dots. So let's say that point in the tree somewhere towards the top, and I'll say a point maybe towards the bottom, right, of the tree. So those are 2 points that I'm kind of concerned with here, right? So what happens is light waves from the sun, right, which we can represent as rays, right, they come down and they hit this point on the tree. They also come down, they're coming down in all directions. So some of them also hit this point on the tree. And I could do this for every single point on the tree, right? I could choose some point intermediate as well. Right now, this tree, it's not actually necessarily a smooth surface. The leaves are not particularly smooth, right? You'll notice if you look at trees, sometimes they're a little bit shiny. Shiny, by the way, you can tell if something is kind of shiny and it's having a good shiny reflection, then it's a smooth surface. It's a specular reflection. But if it's a little rougher, then it's going to be a little bit more flat, right? So tree, it's a little bit more flat, which means that then once this hits the tree, and we know, of course, it's white light leaving the sun, so it's all the wavelengths together. When it hits this tree, then some of those wavelengths are absorbed and then others are reflected. So in this case, at the top, it'd be green wavelengths that are reflected. I don't have a green color. We can say there's green wavelengths that are being reflected in all sorts of directions, right? So they're being reflected all over the place. And some of those reflections end up going back towards your eye, towards the observer's eye. So they can see, right, that this tree, right, this leaf, that part of the tree is right there and it has an actual space